I just started the recording so that folks that aren't here can catch up on this wonderful talk. And I'll provide a brief intro before we get into things. But we're super, super lucky to have Dr. Chip Fletcher joining us today from Hawaii. And he gave 2 guest talks to our previous cohort and has just been incredibly generous with his time in helping us build the Terra community and the climate course experience. Dr. Fletcher, get these notifications out of my way. Sorry. Dr. Fletcher is the Associate Dean for Academic Affairs and Professor in the Department of Earth Sciences at the School of Ocean and Earth Science and Technology at the University of Hawaii. And he is also the Vice Chair of the Honolulu Climate Change Commission. He teaches courses emphasizing earth science, climate change, and coastal community resiliency, and has specific expertise in sea level rise, which he also gave us a specific talk on last cohort. So yeah, we're just super lucky to have him as we've been diving into the climate science, and a lot of people have been asking a lot of great questions on our community chat about climate science, and so now we have a true expert to help us navigate all the information that's been coming at us in the climate science regard. And people have just been really diving into the science and the math and like developing their feel and understanding for the background of like what is happening to us and what can we do about it. So it's just great to have this talk early on in the course. And I think I've enabled screen sharing, and with that, I will turn it over to you, Dr. Fletcher.
Great, thank you. Can you hear me okay?
Yes.
Is that a yes? Okay, good. And I'm going to ask again once I start up my slides if you can see the slide okay. Right now I've got a dark screen.
Yes,
How's
I
that?
can see the climate change. It's worse than
Great.
you think.
Yep. So I am going to spend probably half an hour sort of introducing some basics of climate change. I'm not going to go deep into that because I assume you guys understand much of it. I want to reveal perhaps some information that you are not familiar with, but also that plays a huge role in how things are developing. Then I want to get into some of the peer-reviewed observations that have resulted from the 1.2 degrees Celsius of warming we've seen so far, and then a reality check on how we're doing in terms of cutting our greenhouse gas emissions. So, you know, back in the 90s, it would have been sufficient to work harder at converting from fossil fuel power to renewable power, but now that's not enough. It turns out that renewable power generation is only partnering in next to fossil fuel power generation, not replacing fossil fuel power generation. In the same way, when oil was discovered, it didn't get rid of coal. It simply joined coal as a primary source of power generation. And this is because even, you know, back in the late 1800s and all the way up to today, the demand for new power is growing. The demand for new power, in fact, is growing faster than the rate at which we are deploying renewable energy to replace fossil fuel energy. So we're actually moving backwards. And because of that, this idea of mitigation, which is what reducing greenhouse gas emissions are, is no longer enough. We need to pull carbon dioxide out of the atmosphere. We need to engage in sequestration. Hopefully we'll have a little bit of a chance to talk about that at the end. Sequestration actually is an investment opportunity. You can pull carbon dioxide out of the atmosphere and make things with it that you can sell. You can make things with it that you can then burn. It goes back into the atmosphere and you pull it out again. So this does not reduce the net CO2 in the atmosphere, but it does recycle what's there. In fact, I'm working on a project here in Honolulu where we are going to be making jet fuel out of CO2 that we pull out of the air. use it in our jets. It gets burned, released, and then we pull it out again. It's an opportunity to use these syn fuels or direct air capture fuels to replace fossil fuels. And of course, we have set in motion unstoppable impacts. The Greenland ice sheet is now unstoppably melting. The West Antarctic cluster of about 5 glaciers are unstoppably retreating. And the heat on the continents every summer is unstoppably increasing. So we had better adapt to these very dangerous factors that we had missed the opportunity to prevent. And unfortunately, we still need to educate the general population. Most specifically, we need to educate voters, and we need to educate elected leaders to the reality of climate change so that they can stop relying on hope and instead execute some courage, which is what's needed in our leaders. All right, so the greenhouse effect. Sunlight comes in through the atmosphere. If it hits a white surface like snow or sea ice, it will reflect back out to space and it will not do any warming work. If, however, it hits a dark surface, it will absorb, the dark surface will absorb that sunlight, it will warm up, and then the warmth is released, and that infrared radiation is the right frequency to be trapped by a number of gases in the atmosphere. Carbon dioxide is not the strongest greenhouse gas, but it is one we worry about because it has a very long lifetime. Carbon dioxide, once it's released into the atmosphere, some percentages of it will still be there 1,000 years from now. So you turn on your car this morning, you released carbon dioxide, you have essentially, from a human timescale, permanently polluted the atmosphere. But water vapor is the most important and most powerful greenhouse gas, most powerful. But you all know the water cycle, it's only about 10 days long. So it's not really possible for us to increase the amount of water vapor in the atmosphere. It is possible to increase the amount of carbon dioxide. Well, water vapor will increase in concentration if you warm the air. And so this is an amplifying feedback effect. You warm the atmosphere with, say, carbon dioxide, and for every 1 degree of warmth you get from CO2, you get an additional amplifying feedback because you have increased the humidity of the atmosphere. And so this is a twofer that we wish we didn't get. The carbon dioxide concentration has risen from its natural value of about 280 parts per million. I'm not going to go into paleoclimate. That would be fun to do with you at some point if you guys want to make time. The highest natural value for carbon dioxide in the atmosphere is 280 parts per million. We are now up at 414 parts per million. We're almost at 50% increase over the natural background. And the heat trapping capacity is reflected in the increasing temperature of the atmosphere. So the irregular nature of the heat of the atmosphere is controlled by a number of things. Most of those hot years, the peaks, are related to El Nino in some way. And there are, in fact, super El Ninos like 2015, 1998, 1982. And then most of the valleys, the low points in this curve are La Ninas. And El Nino and La Nina are basically a Pacific oriented process that either stores heat into the ocean by wind shear, and that's La Nina, or releases heat to the atmosphere that was in the ocean by ending the winds, and in fact having them, instead of the trade winds blowing to the west, we get monsoonal easterlies that that blow to the east. And that has the impact of releasing heat from the ocean to the air. But there are longer factors here as well. You'll notice a flattening of the temperature value right after World War II. The thinking here is that the rapid industrialization of the 1950s, 60s, and 70s released enough particulate matter into the atmosphere that it actually blocked sunlight. Well, that's exactly what volcanoes do as well. Climate deniers like to say that volcanoes are natural sources of CO2. Well, that's true, but their net effect is to actually cause temporary global cooling. This plateau of global warming, many people think might be because of the dirtiness of our manufacturing emissions all around the world. And then the US in the late 70s, ironically under the Republican administrations of Nixon and Reagan, started the first of a whole series of Clean Air Acts, and by cleaning up the emissions, allowed global warming to take off again. So we have so far, we have accelerating warming. We have so far warmed 1.2 degrees C. It depends on which data set you look at. I like the NASA Goddard Institute of Space Sciences data set because they collect data up into the Arctic as well as the Antarctic. So for those of you who are in the US, 1.2 C is a little over 2 degrees Fahrenheit. What's the big deal about that much warming? You walk in and out of the shade every day, several times, and you know the change in temperature is far more than 2 degrees Fahrenheit. Well, the way to view this problem is to look at your own body temperature, 98.6 degrees. 2.16 degrees Fahrenheit is equivalent to running a low-grade fever of 100.8 degrees Fahrenheit. And so you have a closed system. You have a small amount of warming, which is capable of severely affecting that closed system, which in this case is your body metabolism. In the case of climate change, it is the troposphere, the lowest layer of the atmosphere. And so this is not a temporary, excuse me, this is not a temporary warming and cooling process. This is a permanent warming, essentially, from the human timescale. The rate of warming is projected to break the first of the United Nations goals of 1.5 degrees C by 2030. In fact, I think I've got this number right. There's been forecast by the World Meteorological Institute a 20% possibility of hitting 1.5 degrees C in any of the next 4 years. By 2045, we're looking at breaking the second of the Paris targets, 2 degrees C. So the rate of warming is accelerating faster than the climate models that are used by the Intergovernmental Panel on Climate Change. So those IPCC reports that come out actually they're widely appreciated as underestimating the threat. How do we know warming is accelerating? There are lots of different ways. One is that over the first 80 years of the 20th century, we set a new global annual temperature record every 13.5 years. And since then, we've set one every 3 years on average. So this is the NASA data set I alluded to. It starts in the last 20 years of the 19th century. You can see lots of spatial variability, lots of temporal variability, but clearly a long-term trend. Notice a couple of factors here. One is that continents warm faster than the ocean. That's why I'm happy to be in Hawaii. We're controlled by an ocean climate. Every summer in the Northern Hemisphere, it's, you know, the news is one heat wave after another, one wildfire after another. And we're only at 1.2 degrees C. When we get to 1.5, and God forbid, 2.0, we're going to be seeing simultaneous failure of global breadbaskets. Now, currently the food distribution system is robust enough to absorb a heat wave failure of a single breadbasket, but it's not robust enough to absorb two simultaneous global breadbaskets of food failing in the course of one summer. When that happens, we see food spikes, and we will see places that do not grow their own food suddenly struggling to get food. And this is one reason why I'm not happy to be in Hawaii, is because we are at the tail end of the global food chain. We are given our food every day by barges and container ships that bring it into us to our ports. And at any one moment, we have a standing crop of less than 2 weeks of food in the state of Hawaii. And this is true of many other island locations. And then you'll notice these blue areas. The North Atlantic is currently the coldest it has been since Ben Franklin began measuring it on his trips back and forth to England. And you'll see the blue areas offshore of Antarctica. Both of these are related to cold meltwater streaming off of the glaciers as they are melting the ice sheets. And we have lowering salinity as well at the same time. And then the last sort of global scale pattern I want to point out to you is called Arctic amplification. The Arctic is warming a little bit more than twice as fast as the rest of the world. And you may have heard about the melting of permafrost and the fear that we are going to release methane in uncontrollable amounts as the permafrost melts. That's been overblown by the press quite a bit, but it is a true potentially catastrophic effect once we get above 2 degrees C. So about 86% of the greenhouse gases that are released by humanity come from burning of fossil fuels, and about 14% comes from various types of land use, including deforestation. Of this release, about 44% goes into the atmosphere, 29% is absorbed within 1 year's time into the photosynthesis cycle, and the remainder, 23%, is dissolved in the ocean, creating ocean acidification. Greenhouse gas emissions currently are at about 40 billion tons of CO2 per year. If you want to do CO2 equivalent, which sort of crams all the other types of greenhouse gases in an equivalency to CO2, you're up around 44 billion tons of CO2 equivalent released every year. That is the guideline for sequestration. And when you look at sequestration efforts, you find the ability to withdraw CO2 on the order of millions of tons, a few million tons per year. Well, that's an amazing accomplishment, but far, far, far away from what we need to be doing. China is the world's largest emitter at more than 25%. But when you count back through time, just the last 40 years, the US is the largest cumulative emitter, responsible for 25% of the greenhouse gases that are up there. The poorest countries of the world, the developing nations, emit less than 1% of greenhouse gas, but they suffer the greatest impacts. And under current policies, we are on a pathway to between 3 and a little over 3.5 degrees C, 3.1 to 3.7 by the end of the century. So there's your body temperature, a pretty nasty fever that you need to go to the hospital. And here's this 20% chance at any 1 year in the next 4 years actually peaking at 1.5 and then probably diving back down again in the following years. Fundamentally, this is the relationship that needs to be broken. We have atmospheric CO2 on the vertical axis and world economic activity, GDP, on the horizontal axis. And since World War II, we have a near linear relationship of the growth of global wealth. And, you know, we have benefited in the developed world enormously. Our quality of life is extremely high. The developing nations of the world are struggling hard to catch up to us, and that's actually the source of most of the new demand for power that's being met largely with fossil fuels. But in the process, we have poisoned ourselves. And we need to break this relationship. And we need to get away from the idea that economics is based on growth. Because in addition to climate change, we also have the fact that we have overpopulated this planet. And resource depletion, deforestation, pollution, the loss of wild places, the destruction of natural biodiversity, all of these are happening parallel to climate change. They are enhanced by climate change. They in turn enhance climate change, but they are related to our overall Western model of extractive economics rather than regenerative economics. And so there's some fundamental changes that need to take place there. So with only 1.2 degrees C of warming, I could have about 20 slides of the evils that have been documented. Antarctic ice melt has tripled over the past 5 years. Greenland melting has quadrupled. Greenland and West Antarctica are irreversibly melting. There's a 1 in 20 probability of sea level rise reaching 6.5 feet by the end of the century. So 1 in 20, 5%. If 1 out of every 20 airplanes crashed into the ground, you would not fly. We would not have an airline industry. A 5% probability is certainly a sufficiently dangerous probability to make some very important decisions, such as communities on the coastline reacting now with their CIP decisions and other types of budget decisions and development decisions being defined in terms of either adapting to, either living with or avoiding 2 meters of sea level rise. We've seen a 12% increase in extreme rainfall and a 10% increase in drought. Climate change amplifies this problem of overpopulation. We have altered 70% of the world's lands with mines, roads, industrial farms, cities, and airports. 40% of the world's original forests have been eliminated. Since 1970, each of us consumes 45% more stuff than we did back then. And world GDP has grown by 300%. Today, 66% of humans face a water shortage for at least 1 month each year. Over 33 million people were displaced from their homes last year. Climate change played a role in 70% of these cases, often with extreme weather events. Poor women are 14 times more likely to die from a climate-fueled disaster than men. The Syrian conflict that gave rise to ISIS and has changed the political face of Europe, think Brexit, and that's not the only example, started because of a drought, a 1,000-year drought, we know that from tree rings, that collapsed farming in Syria and other parts of the Middle East and sent these farming families into urban areas, Aleppo, Damascus, and there they found a lack of government services and evidence of the corrupt government of Bashar al-Assad. And the young men created a rebel force in a civil war. The US at the same time was pushing al-Qaeda out of Afghanistan and Iraq, and they found haven in the political chaos of Syria, the Syrian civil war. And we had a 4 million person refugee problem from 2015 that is still going on today, all rooted in a drought made 2 to 3 times more likely by climate change. Annually, extreme weather disasters cause more than 60,000 deaths. Hurricanes are changing in ways that are making them much more dangerous. And IAG, the insurance giant, wrote, "Failure to reduce greenhouse gas emissions could result in a world that is uninsurable, with poorer communities bearing the largest burden." All right, I see several things in the chat box.
Yeah, feel free to get to those now, or I can kind of keep track of them too, and we can save them towards the end. But just looking at them, some of them are more relevant to exactly what you're talking about than others, and others we can get to. Yeah.
Has anyone come across online discussions where people use this graph to argue that CO2 is following the temperatures and not the other way around? Actually, what they use is ice core graphs, and they look largely at the transition from the last ice age up to the current interglacial that we live in. The problem with ice core data is that it's very difficult to sample it with enough granularity to show the exact temporal relationship between CO2 and temperature. And the coarse records that have been published for many decades from ice core scientists have shown temperature rising before CO2. Well, 2 or 3 years ago, an extremely granular, fine-grained sampling of ice core, trapped air bubbles in ice cores showed that, in fact, CO2 rose first and then temperature rose. We need to change our current trend. Yes, great comments here. So don't we need a new measure of growth to identify which country, yes, that's wonderful, is progressing in a more healthy way? This will help to show a new path on a global scale where a country like Bhutan can come at the forefront. Yes, although I hear some things about very authoritarian governments in Bhutan. I don't know a lot about it, so I should probably be quiet. But yeah, gross national happiness, which they measure. What's the relative impact of reduction in existing demand by some percentage versus reduction in new demand? That's a good question. I don't really have an answer for you on that. But, so the EU has been reducing their emissions. The US has been reducing their emissions. A lot of this is tied to the rise of natural gas, which has less carbon, or is a little cleaner than oil. But India and China are the primary emitters that are coming on strong, because especially India and its huge population of over 1 billion people wants to enjoy reliable, clean water, food access, health, transportation, education, and they deserve it.
Mm-hmm.
Some of the papers that come out just blow my mind. In fact, I'm not showing you one that really blew my mind about 3 weeks ago, where they said the current rate of deforestation is going to cause the collapse of human civilization in 2 to 4 decades. And it was just this math-intensive paper by a couple of physicists, and it came out in Nature. But this one is very striking. Pervasive human-driven decline of life on Earth points to the need for transformative change. And it says the world is increasingly managed to maximize the flow of material contributions from nature to keep up with rising demands for food, energy, timber, and more, with global trade increasing the geographic separation between supply and demand. This unparalleled appropriation of nature is causing the fabric of life, on which humanity depends, to fray and unravel. I'm sure most of you are aware, in 2015, The world's nations agreed to stop their emissions before reaching 2 degrees C and to pursue efforts to end warming before 1.5 degrees C. The Achilles heel of this agreement was that it's self-policed, right? So there's no penalty if the emissions of your country do not meet the promise that was made by your country in the Paris Agreement. And so even the Paris Agreement was 3 times more emissions, or got all the nations to promise to go to a level of emissions that is 3 times more than is consistent with stopping at 1.5 degrees C. But the plan is to ratchet down over the decade of the 1920s. But it's not happening. As a world, the announced future plan for emissions and energy production and the current put us on this pathway to over 3 degrees C by the end of the century. Sorry about Marley there, that's my dog in the background. He'll be quiet in a minute. So I mentioned this to you already. Fossil fuel use is accelerating faster than renewable fuel use. This data, or the latest data point here, is from 2019. This goes back to 1960. The rate of increase of oil, coal, and gas is greater than the rate of increase of all those non-carbon energies down below. And so, as I said, renewable energy is not replacing fossil fuels. It is simply helping to meet the demand for new energy. And the question of, well, what are the projected emissions in the future? This list over here on the left is various types of global energy economists. Yes, we see BP and ExxonMobil, et cetera, the lying criminal corporations that have driven us into this problem, feeding more and more junk to the junkie, if you will. But those folks are also, their economists are very smart, very well informed, and so there are sort of non-commercial and non-partisan projections of emissions in the future, and then there are these commercial projections. They all agree. They all say the same thing, that energy-related CO2 emissions are projected to continue increasing towards mid-century. And these are the pathways we need to follow to the Paris targets. So here is our history of CO2 emissions from 1850 up to present day. And in order to meet the Paris target of 1.5, we have to have 0 emissions by 2050. This literally means stepping off a cliff in the year 2020. And we did it. Well, a virus named COVID-19 did it. We've actually, because of the reduction in emissions this year, because of the pandemic, we don't know we don't have the final numbers for emissions for 2020, but they will be in the ballpark of 5 to 7% reduction compared to previous emissions. And that's what we need to do every single year. Another way to put this is the emissions reductions that come from the recession of 2020 need to be repeated every other year until 2050. And there's the pathway to 2 degrees C reaching zero emissions 15 years later. So that's as a global community. But if, as we said, we want India and the rest of the developing world to have these stable infrastructure features in their lives, they actually need to be permitted to continue burning fossil fuels, because the construction equipment and the electricity that they currently have in place is fossil fuel driven. The infrastructure that is there that will allow them to build the type of safe community that the developed world has means that the developed world needs to reach zero emissions within 10 years. So for global equity, social equity, the developed nations need to reach zero carbon emissions by 2030, giving time to the developing world to increase their public infrastructure and burn fossil fuels to do it, while they simultaneously make extremely aggressive advancements on deploying renewable energy. And above and beyond all this, regardless of how quickly we reach zero emissions, let's say we do reach it by 2050 or even 2030, which is an impossibility, we need to remove CO2 from the air for the next several centuries. And this is because the air temperature today is a product of emissions an average of 10 years ago. There's a lag. The lag is anywhere from 5 years to over 30 years from the moment you turn your car on and you release greenhouse gases out the tailpipe to when those greenhouse gases actually begin to trap heat in the atmosphere, a time lag. So what we see today is a product of our emissions, an average of a decade ago. The truth is, renewable energy provides only 10% of global power. The top fossil fuel producing nations are on track and have announced plans to produce about 50% more fossil fuels by 2030 than is compatible with stopping warming at, this must be 1.5 degrees. Actually, I'm not sure if that's 1.5 or 2. China is building more new coal plants than the rest of the world combined. India is opening 41 new coal mines as part of its post-COVID recovery plans. Coal remains the single largest source of power generation, accounting for 36% of global power, right? Coal remains the single largest source of power generation, accounting for 36% of global power. Renewable energy provides only 10%. To get to net zero, as I said, we need COVID-like reductions in carbon emissions every other year. And this can only be achieved by a radical shift in all our behaviors. COVID is forcing us to make that shift, but what will the post-COVID economy look like? Are we going to come roaring back powered by fossil fuels? Are we going to come back slower but powered by renewables? Is COVID here to stay as a quasi-permanent condition that suppresses economic growth? As painful as that is, it offers the possibility of saving modern civilization. So this paper is the last time that a model was run predicting future climate, future warming. This model is on the basis of economic activity. And so the likely range of warming is 3.6 to 8.8 degrees Fahrenheit with a median of 5.5. I'm sorry for some of the errors here in Fahrenheit versus Celsius. I think I was preparing some of these slides for a business community talk, and I wanted to do everything in Fahrenheit. But as I said, the median is 3.2 C, not 5.5 C. This will lead to food and water disruption, weather disasters, global scale refugee crisis, which we'll talk about in a second, and highly damaged ecosystems with sea level reaching potentially 5.5 meters in 200 years. All right, this paper really rocked my world. It came out earlier this year in May. So you can see those black areas in the Sahara Desert. Those black areas represent 1% of the current land surface. And at those locations, a healthy person can be sitting in the shade with all the water they want and begin to experience heat disease within a few hours and organ failure after 5 or 6 hours. So it's just too hot for our metabolism to push heat out through our skin. So that's today, those black areas in the Sahara. And in only 50 years, the models project those conditions will expand to 20% of the land surface, every place that has a diagonal dark brown shading. So we probably lose all of the Amazon just to the heat if we don't damage it ourselves from deforestation related to farming. Look at India, the Middle East, Southeast Asia, Northern Australia, North Africa, and even up here in Central America. So although these temperatures are currently too hot for human existence, that temperature can come down too hot for human existence if the humidity goes up. That's called the wet bulb temperature. And there are a number of papers that project wet bulb temperature beyond human endurance, expanding to even larger areas of Earth's surface. I won't get into those. I'll do those on a longer talk. So here's our CO2 emissions. We had an increase of 1.5% in 2017, over 2% in 2018. Things were starting to plateau in 2019, but we had a plateau back in 2014 as well, 2016. And this year we see our first negative emissions, but we are on a pathway now to over 3 degrees C by the end of the century. So I'll end with that before I go into this next chapter. Let me stop sharing and end the show, and we can have any sort of discussion that you like.
Awesome. I've been tracking the chat a little bit. A lot of it has been just comments and reactions to these slides that you've been sharing, which are, yeah, incredibly crazy and mind-blowing to see. But yeah, going back to some of the questions, let me just, back up a little bit.
There we go. And let me dash off and freshen my coffee. I'll be less than 15 seconds.
Yeah, please. I'm just trying to see where about we left off. I think around Charlie's question. Yeah. And Charlie, just briefly on your question, the class 7 that's releasing tomorrow, I believe, is about a lot of different alternative economic models and systems that'll help answer that question about regenerative economies and not extractive economic systems. So there are a few examples that will be highlighted in class 7. Cool. So I was just going back in the chat to a string of questions that came in. One was from Charlie, and I'll let you touch on this, Tip, maybe any examples of how we can shift our economic system to one that is regenerative instead of extractive.
Yeah, so Um, that's a very good question. There's a lot of talk about a circular economy, especially here in Hawaii, but I don't hear people diving into the details. You know, a relatively small contained community like Hawaii, I can't get an economist to answer the question or to research the question, can we maintain a high salary level and quality of life if we focus on renewal and replacement rather than expansion and growth? You know, if we focused on all our building materials coming from here in Hawaii, if we use carbon negative concrete, which by the way is available now around the world, and I was reading yesterday about greatly reduced carbon steel. And I don't have a clean answer to that, but I would propose that it's going to be small communities that offer the advantages of scale to get to define what a regenerative economy is. The second thing I would say is that there is clearly regenerative agriculture, right? The deep plowing, the turning the soil over and exposing the carbon in the soil to the air so that our fields become sources of CO2 versus not furrowing our soil, using cover crops which put essential nutrients back into the soil. We can, it's been shown that we can take the average carbon content of our agriculture fields from their current level of 1% carbon and raise it to 3% carbon. And that's what their natural carbon content should be. We can do that with regenerative farming practices, and that will pull a huge amount of CO2 out of the atmosphere. So agriculture offers a very important solution in this problem.
Yeah, agreed. Nikhil had a question, and then Iwank, and then I think I'll go down to the end because then there were just a bunch of comments. Nikhil, do you want to ask your question or do you want me to summarize it?
So one question I think was in terms of technologies, how much is already there and what needs to be scaled up versus what needs more research?
Yeah, good question. So we have all the tools already in place to do what we need, but there's a constant search for solar cell materials with greater efficiency. There is the political battle of putting windmills offshore. Offshore wind offers a huge opportunity. In fact, it looks like England may meet its Paris requirements largely through offshore wind. The sequestration problem is one of the areas where there's an enormous growth needed in the technology there. You can pull CO2 out of the air, but the energy to do that is enormous. So you don't want to be burning fossil fuels in order to pull fossil fuels out of the air. We've calculated that a direct air capture plant that would provide enough jet fuel for Honolulu Airport would require over 1,000 acres of solar panels. And we don't have that available. So we're turning to the ocean to generate hydrogen. And the idea of putting out a series of large autonomous drones that will use wave energy to generate the electrolysis to release hydrogen, and then using that hydrogen as a source of energy is something we're working on with a private company. It doesn't exist yet. They have done the background work to say that it's entirely possible. So that's an example of where technology still needs to still needs to increase. So the answer is yes, there are lots of places where we still need the technology, although had we chosen to in the 90s, you know, we could have stopped the problem with the existing technology.
Mm-hmm. Mm-hmm. Yeah, great answer. And looking back through some of these other questions, Satyaji added on is sequestering carbon a net negative process. I think more so in the case of regenerative agriculture that you were talking about than like the carbon recycling process of removing atmospheric CO2 to use it for jet fuel and burn it again. But yeah, is that?
Yeah, that is not net negative.
Yeah.
But, you know, improving the technology and building up the infrastructure that pulls CO2 out of the air is important to do. And wouldn't it be interesting to have, you know, global tourism is the number one economy in the world. It's the number one economic driver in the world. And global tourism takes place with jet travel, with aviation. Now, aviation is only responsible for about 2.5% of greenhouse gas emissions. But wouldn't it be amazing if the infrastructure to pull CO2 out of the air were to spread across the world in the next 10 years so that jet fuels were being made at every major airport? You could, at the same time, pull more CO2 out and inject it into the ground and permanently sequester it in reservoirs in Earth's crust. So then it can be a true negative funded by the tourism industry.
Yeah, great point. I think, we need to, develop these technologies so that we can scale them and use them in different applications as well. And and I'm personally curious to read a little more on how removing CO2 from the atmosphere can be used to make certain products. I think that's interesting. And I've read a few things about that from the beer industry, for example, using removed carbon dioxide for their bottling processes. Okay, I'm going to try and get to like as many as I can in the next couple of minutes. And if people have to drop off right at the hour, that's great. But I think, Dr. Fletcher, you can stay for another 10 minutes or so. Is that, okay, cool. And I'll just keep recording. Srini had a question. Okay, awesome. Srini, do you want to ask your question about solar power prices and fossil fuel subsidies and sort of the replacement opportunities there?
Hello, Dr. Fletcher. So yeah, my question is, why aren't you optimistic about solar power becoming cheaper and replacing fossil fuels?
So I am optimistic about that, and it's become incredibly cheaper. It's truly a modern technological miracle how the price has fallen and the efficiency has risen of wind and solar, and the deployment of these has increased. It's been unbelievable. So I'm very optimistic about that. But the fact is, it's not replacing fossil fuels. It's not replacing fossil fuels. And so there's something missing there. We need to not only deploy these sources of renewable energy, we need to change our lifestyles. We need to help the developing world not go to McDonald's, right? A lot of what's happening in the developing world is that the worst of the developed world is being embraced. And the taste for meat, for beef, and chicken and pork has spread to the developing world. They are embracing McDonald's and Burger King, and the beef industry is the primary reason why deforestation is taking place, because we need to deforest tracts of land in order to grow the soy and corn that is necessary to feed the 10 billion cows, and it might even be more than that now, that are on the planet that we treat horrendously and torture in order to provide hamburgers and steaks to the billions of people who never had access to them before and have decided now that they want access to these. So sorry that I took a tangent over there, but it's not about the technology of the sun and the wind. It's about changing the extractive model of humans living on a planet.
Thank you, Dr. Fletcher.
Yeah, great, great question and great responses. Let me see. What was I'm trying to go in order here. Sorry if I'm forgetting yours, and feel free to just put it in again. Satyaji, you want to ask your question that came up in there?
Yeah, I wanted to know why more countries aren't following the the footprint of France and adding more nuclear power plants. Because I remember India being very much interested in following the same route of nuclear power being one of our biggest sources for renewable energy. I don't know what happened to that, or has Fukushima scared a lot of countries? Because I know that Germany started shutting down the nuclear power plants after Fukushima happened. So I'm curious what's happening there, and if there's any concerted effort into exploring that.
Yeah, Fukushima was alarming. And the amount of cement that's used in nuclear power plants is massive. However, there's a type of cement called carbon cure, and there are others. We know that we can make cement that actually pulls CO2 out of the atmosphere. That's net negative. And there is technology out there for nuclear power, like pebble bed reactors and others that have been around for a while. I think there's a new way to do nuclear power, smaller scale, less dangerous, with lots of backup systems to increase the safety. Your question was, why isn't India embracing that? I really don't know. But I think nuclear power does have a seat at the table, provided it's in a new fashion and not the old style of massive, huge nuclear power plants.
I think to answer your question, why India is not embracing it is, I guess it's more of a political issue where countries like China and US don't want India to become a nuclear power, a more advanced nuclear power, I guess. Because I remember this is exactly what they said during the Paris Agreement. But yeah, I guess I was curious why other European countries aren't following the nuclear way of doing things. Yeah.
Yeah, good question. I need to look into that.
Yeah, thank you guys for that. And I think we might organize a separate discussion section or just a discussion time to chat about nuclear power, because that came up as a big question mark and, just controversy in many people's minds that is just worth talking about more and airing out, because the past is not necessarily the precedent that we want to follow, but it really might be an important part of the solution. So I'm going to ask, go ahead.
Nuclear power plants, to get the permitting can take many years. Then the construction can take many years. So, if we decide, let's go down the nuclear power path right now, it may be more than a decade before you're actually implementing it.
Yeah, definitely. That's a good point. And the cost overruns can really there's just a lot of concerns with that whole permitting and cost factor. I'm going to ask Keisha's question for her. She just had to drop off, but messaged me that, she'll check out the recording. But her question is, here in the US and in many other countries also, we are at the mercy of a broken political system and profound corporate greed. What is the scientific community's best hope for combating this? And what is its responsibility in the fight?
So
interesting.
I am extremely disappointed in my scientific colleagues. There still tends to be this ivory tower attitude that scientists should not play a role in influencing politics or getting out and being an influential force in public discussion. I can't think of a better cohort of people to do exactly that. So it's very disappointing. However, there are a whole bunch of climate scientists that are out there very vigorously engaging in public discussion. So there are, there are lots of exceptions to this. what was it? Oh, yeah, broken political systems.
Yeah.
Boy, you tell me.
Yeah.
I don't know.
I
The
know.
tribalism, right? The tribalism, the us them, the embracing of immoral positions. It just seems it's the separation of parties, and at least in the US, and the us them attitude is just getting worse and worse and worse. I don't know what the solution is to this.
Yeah, me neither. But I'm hoping we'll get some change this fall in the
I'm
US at
hoping
least.
so. Yeah.
Iwank had a question that he posted again from before. Iwank, are you able to unmute yourself and ask it? And then maybe just this and one more is what we'll have time for.
So I had a question though. Few days back, I was reading about this concept that you mentioned about carbon sources equal to carbon sink. So this question of this missing carbon popped up, where it talked about how much like carbon sources are greater than the absorption, like the sink. So in reality, is there a missing carbon kind of concept there? If it's there, where does the missing carbon goes?
So are you talking about an inability to close the carbon budget emissions
Yeah.
versus where they go? I
Huh.
mean, so I had one slide on that, and the misfit was only 4%. So I have not run across that as a big issue. But if you have sources that are telling you that we aren't able to come anywhere close to closing the carbon cycle, I'd love to see them. I'd love to see them.
Yeah, please share, Iwank, and we'll keep that discussion going. Let's see. Questions. What about climate adaptations then? Samyak, you had a question about climate adaptations, like what we should be doing now, or do you want to clarify that at all? And maybe we'll end on that. What can we do about adaptation, and what can we do as people who are trying to self-educate?
Yeah, that's
on
right.
climate change?
If this problem is not going to be solved in the near future, then we'll have to adapt to what's going to happen to our climate and what are the best measures for that. So should we like stay away from the coast, all those kind of measures? What is there any plan for that? Plan B sort of?
So that's all being handled at the local level, at least in the United States. It's up to cities and local governments to figure out what the plans are to adapt to sea level rise, heat, extreme weather events, and turning to federal level for resources to help them both develop the concepts behind adaptation as well as to fund the necessary adaptation. So this is something we're working on in Hawaii specific to sea level rise. What parts of our community want to stay where they are and be flooded, but develop in a way that allows for flooding? How can we still have placemaking, urban locations that are shady and attractive in floodable landscapes versus absolute retreat from the coastline we're thinking for smaller villages and towns where you just have to get out of the way of sea level rise. Now, our current set of policies and laws in the United States, at least, do not recognize sea level rise. And there are really no true solutions that have been developed on how to retreat from the coastline. There's talk about strategic retreat and managed retreat, but it stays at the 30,000 foot level. There are examples of where federal money is available to buy up individual properties that have been hit by hurricanes, but it's not all about hurricanes. Sea level rise is also about non-storm flooding that takes place. And There are no solutions there for that. But having spoken about sea level rise, I think the true danger is about heat. It's heat. And adapting to heat, ultimately, just like with sea level rise, if you are in a place that's going to heat up beyond human tolerance, if you are on a coastline that is going to be flooded with 1 or 2 meters of sea level rise, your location is doomed. You've got to move. And you can either move now, or you can move as the result of an extreme weather event and join a whole bunch of other people that are moving at the same time, which makes it all that much harder. So as you mentioned, we cannot stop a lot of these things. And part of the adaptation mechanism is to recognize what the future holds in terms of heat and sea level rise and storminess and declining water availability. And to modify your personal plans and your family plans in a way that takes them into account and plan for the future of your children and your family.
Yeah.
And it's not all about just us personally. I am deeply embedded in community decision making and deeply embedded in service. All that is extremely important as well.
So true. So let's just kind of wrap up on any concluding thoughts that you have, Chip, that you want to share. And, you know, just knowing that people are on their climate journeys looking for new lines of work or new aspects of incorporating climate change into what we're all doing professionally and personally. If you have any advice or suggestions other than, find a safe place that's not going to flood or be inextricably hot. Yeah, we would love to wrap up on that note.
Well, you're doing the right thing by being part of this class and furthering your education. I think it's extremely important to get the unvarnished truth. And the unvarnished truth is out there in terms of peer-reviewed scientific articles and studies. It's not about hope. Hope is not a strategy. It's about courage, making changes, demanding changes, getting involved and implementing changes at all types of levels, from personal to global. If everybody gets on board and you know, changes personal behavior and figures out, you know, what's their sweet spot in terms of changing community, state, national, international, and global behaviors, I think change can happen. But it takes courage to step out of our lanes. It takes courage to step out of the comfort zones of our lives. But that's what needs to happen.
Yeah, well, thank you so much. This has been incredibly informative and just a wonderful complement to what we've been diving into so far in the course. And yeah, if anyone has further questions, I'm happy to keep them on file. I'm going to save this chat and the recording, and I can pass some of them along to Dr. Fletcher, assuming he's willing to answer them. And it's just wonderful to be, thank you. It's wonderful to be part of this supportive community of learners, educators, researchers. That's really, makes me feel like I can get my courage together. So thanks all. And I'll stop the recording here.
Okay, thank you. Thanks for all of you. It was a fascinating discussion. You guys are on the right road. Thank you.
Have a good rest of your day, everyone.